Hey guys, welcome back to Zero to Tech. No theory, no noise, just real skills. So today we will be covering the last room of Web Fundamentals, that is putting it all together. This is the last room under the module called How the Web Works. So there's the room. Learn how all the individual components of web work together to bring you access to your favorite websites. Okay, so let's begin without wasting any time. Putting it all together from the previous modules, you will have learned that quite a lot of things go on behind the scenes when you request a web page in your browser. To summarize, when you request a website, your computer needs to know the server's IP address it needs to talk to. For this, it uses DNS. Your computer then talks to the web server using a special set of commands called HTTP protocol. The web server then returns HTML, JavaScript, CSS images, etc., which your browser then uses to correctly format and display the website to you. There are also a few other components that help the web run more efficiently and provide extra features, right? Okay, so move on to the next task. Load balancers. Okay, this is an interesting topic. This will be useful in the future tasks, so remember this part carefully. Okay, so let's read about it. Load balancers, when a web site's traffic starts getting quite large or is running an application that needs to have a high availability, one web server might no longer do the job. Load balancers provide two main features: ensuring high traffic websites can handle the load and providing a failover if a server becomes unresponsive. Okay, so it's basically a fallback system. Okay, when you request a website with a load balancer, the load balancer will receive your request first and then forward it to the multiple servers behind it. The load balancer uses different algorithms to help it decide which server is best to deal with the request. So load balancer basically sits in between, as you can see in this diagram. This is the load balancer, and when you request a website, the request first goes to the load balancer, then it checks that which server to route to for the link or for the website that you requested for, right? If suppose so this is server 1, this is server 2, this is server 3. So suppose server 1 and server 2 are busy, so it will redirect you to server 3 and you will get your web page from server 3, even though your website was also there in server 1 and server 2, but it will send the request for server 3 just because server 3 was free enough and server 1 and server 2 were busy providing services to other clients, right? Okay, a couple of examples of these algorithms are round robin. You will read this topic if you are a computer science student and had your subject of operating system. So you would have read this subject basically, sorry, this topic. So which send it to each server in turn or weighted, which checks how many requests a server is currently dealing with and sends it to the least busy server, as I told you. Load balancer also perform periodic checks with each server to ensure they are running correctly. This is called a health check. If server doesn't respond appropriately or doesn't respond, the load balancer will stop sending traffic until it responds appropriately again. Okay. So content delivery network, CDN. A CDN can be an excellent resource for cutting down website traffic. Cutting down traffic to a busy website. It allows you to host static files from your website, such as JavaScript, CSS, images, videos. Host them across thousands of servers over the world. When a user requests one of the hosted files, the CDN works out where the nearest server is physically located and sends the request there instead of potentially the other side of the world. So suppose CDN basically works, how CDN works is like that there are some servers out there and all the servers have the same files with them. And suppose you are in Mumbai and you are requesting a website and the nearest server to you is near Delhi. So you will get the file from Delhi. And suppose you are in Kolkata. I'm talking about India only because I'm not sure about the other countries in the world. But yeah, I'm definitely sure that CDN works in the rest of the world as well. But as I know the states of India well, that's why I'm referencing India. So yeah, let's come back to the topic. So suppose you request the website from Kolkata and the nearest server to Kolkata was Bangladesh. So your files will come from Bangladesh and not from the one that is in Delhi, because your nearest server is the one that CDN basically redirects you to, right? Databases. Often websites will need a way of storing information for their users. Web servers can communicate with databases to store and recall data from them. Databases can range from just a simple plain text file up to a complex cluster of multiple servers, providing speed and resilience. You will come across some common databases, MySQL. These you will read all this stuff when you learn about DBMS, database management system, and all. So let's go. Each has its specific features. Web application firewall, WAF, sits between your web request and the web server, just to check that what request you are making is malicious or not, and the response that is coming, if it is malicious or not. Its primary purpose is to protect the web server from hacking or denial of service attacks, right? It analyzes the web request for a common attack technique, whether the request is from a real browser rather than a bot. It also checks if an extensive amount of web requests are being sent by utilizing some called rate limiting, which will only allow a certain amount of request from an IP per second. If a request is deemed a potential attack, it will be dropped and never sent to the web server. Right? Okay, let's solve these questions. What can be used to host static files and speed up a client's visit to a website? And that is CDN. What does a load balancer perform to make sure a host is still alive? So it does a health check to see if the host is still alive. So we'll do health check. We'll click on check. What can we use to help against the hacking of a website? We use WAF, that is Web Application Firewall. Okay, on to the next task. How web servers work. What is a web server? A web server is a software that listens for incoming connections and then utilizes HTTP protocol to deliver web content to its clients. The most common web server software you will come across is Apache, Nginx, IIS, and Node.js. A web server delivers files from what's called its root directory, which is defined in the software settings. For example, Nginx and Apache share the same default location of var HTML, and this is the location in Linux operating systems, and IIS uses this one in Windows operating system. So, for example, if you requested the file, this one, it would send the file from this location, from its local hard drive, right? Virtual host. A web server can host multiple websites with different domain names. To achieve this, they use virtual host. The web server software checks the host name being requested from the HTTP headers and matches that against its virtual hosts. Virtual host adjusts text-based configuration files. If it finds a match, the correct website will be provided. If no match is found, the default website will be provided instead. Virtual hosts can have their root directory mapped to different locations on the hard drive. For example, 1.com mapped to this location and 2.com mapped to this location, right? There's no limit to the number of different websites you can host on a web server. Static versus dynamic content. Static content, as the name suggests, is the content that never changes. Common example of this are pictures, JavaScript, CSS, etc., but can also include HTML that never changes. Furthermore, these are the files that are directly served from the web server with no changes made to them. Dynamic content, on the other hand, is content that could change with different requests. Take, for example, a blog. On the homepage of the blog, it will show you the latest entries. If a new entry is created, the homepage is then updated with the latest entry, or a second example might be a search page on a blog. Depending on what word you search, different results will be displayed. These changes to what you end up seeing are done in what is called the backend with the use of programming and scripting language, as we talked about this earlier actually. It's called the backend because what is being done is all done behind the scenes. You can't view the website's HTML source and see what's happening in the backend, while the HTML is the result of the processing of the backend. Everything you see in your browser is called the front end. Scripting and backend languages, there's not much of a limit to what a backend language can achieve, and these are what make a website interactive to the user. Some examples of this language in no particular order are PHP, Python, Ruby, Node.js, Perl, and many more. These languages can interact with databases, call external services, process data from the user, and so much more. A very basic PHP example of this would be if you requested the website this one. If index PHP was built like this, the it would output the following to the client, right? So how is this going? Is going to hello. and then the client name. So client will basically putting their name, and that name will be reflected in the output. So hello Adam. So suppose if you say hello Joy, if you enter your name like Joy, so it will come up like hello Joy. And if you give your name like hello Rahul, so it will come up like hello Rahul. Okay, like that. You will notice that the client doesn't see any PHP code because it's on the backend. This interactivity opens up a lot of more security issues for web applications that haven't been created securely, as we will learn in further modules. Let's solve these answers. What does web server software use to host multiple sites? And as we saw, this is the one that they are talking about, virtual host. What is the name for the type of content that can change? And it's dynamic content. I know that. I'll just copy and paste it. I guess it's only one thing, only needed the dynamic part. Does the client see the backend code? No, we don't see the backend code. We don't see the PHP code. We only see the processed output. Take the quiz. Click the view site button on the right. Use everything you have learned from the modules. Drag and drop the tiles into the correct order of how a request to a website works to reveal the flag. When placing a tile in the correct position, it will highlight in green. When a tile is in the wrong spot, it will highlight in red. Make sure not to refresh the page as it will reset the tiles all to blank again. Okay, so let's get the flag then. There we go. We have these. So, okay, what does it want? Request tryhackme.com. This is the first one. Okay, now my browser basically checks for local IP addresses, right? And then if it doesn't found the IP address, then it will check the DNS. No? Yep, yes, I'm right. Then after doing that, what is the next process? Query root server to find an authoritative DNS server. Okay, and then authoritative DNS server advises the IP addresses for the website. Then request passes through a application firewall, and then request passes through a load balancer. Okay, and then so this one, of course, connect to web server on port 8443. After that, the web application receives the get request, and then web application talks to the database for our data, for fetching our data, and then it sends the data, and our browser renders the HTML, and we got the flag. And with that, guys, we have successfully completed a whole module of TryHackMe, and you guys are awesome. You guys keep supporting me throughout this whole series. So now next we will be moving to the next module of TryHackMe, and let me show you which module I'm talking about. Okay, so I'll just close all this and I'll show you which module I am talking about. So this is a new module that I'm talking about. It's a long module and it's an interesting module. There will be a lot of hacking stuff going on here, and you will get a hands-on experience on the actual stuff, actual hacking that happens in the real world, and you'll get to experience those. So stay tuned with me, guys, and a lot of content is coming up. And remember that these contents are not free of cost. These are actually paid rooms that I will be covering for free for you guys, so that you guys don't have to pay your money. You guys just have to subscribe to my channel and I'll show you how it's done, right? You can even pause my videos and you can read on your own if you don't like my reading style, right? It's on your own totally. You are free to do that, guys, and I encourage that, right? Okay, guys, thanks a lot for watching today's video. Please like, subscribe to my channel, share these videos so that even your friends and colleagues can get these videos and get some idea on cybersecurity and get some education on cybersecurity. We need education on cybersecurity these days because the rate at which AI is increasing, cybersecurity stuffs is also getting more critical, right? So thanks a lot for watching today's video. Have a nice day. Signing off. Good night.